Okay, students, going to give this another try. The previous video that I uploaded seemed to work, but the image was pretty pixelated. I think I've got that solved, so here we go again. The lesson for Monday is on vertical shifts. We're going to be taking the parent functions that we worked on for Friday, and we're going to begin making all kinds of changes to the equations and to the graphs so that we can observe the changes that occur. If you change the equation, how does the graph change? And if you change the graph, how does the equation change? Things like that. So let's begin. All right, today's objective, the student will discover the effects of a vertical shift upon parent functions and their equations. The date for this lesson will be Monday, September the 16th. So copy your objective and your date. And as always, press pause if you need any extra time, and then press play when you're ready to go again. All right, for the next few lessons, we're going to be looking at various changes that can be made to the parent functions and see what effects they have on the graph. And the first change, as we said, will focus on what is called a vertical shift. Okay, now a vertical shift does exactly what it sounds like it does. It simply moves the location of the graph up or down. Okay. And the way it does this is in an equation, a vertical shift is found by looking for a constant that is being added or subtracted to or from the entire equation. Now that's going to be different from a constant being added or subtracted to particular parts of the equation, and we'll get into that in the next couple of days. But the vertical shift occurs from adding or subtracting a constant to the entire equation like this. Okay, so basically what you're going to have is an equation that says y, or f of x, equals, then you will have something going on with the independent variable. Square root of x for a square root function, or absolute value of x for an absolute value function. Okay, whatever is happening to the x, that is fine, but then there will be a constant being added or subtracted to either the end of the equation, like you see on the first example there, and that's the proper way of doing it, but it does not mean that it cannot happen where the constant is actually added towards the beginning of that expression, like it is shown in the second example. Okay, so let's take a look at some of the changes to the parent functions that we have discussed so far. Okay, here we have a particular function. What type of a function will this one be? This one is quadratic, and we know it's going to be quadratic because we have y in the first dimension, and then we have another variable x in the second dimension. When you have one in the first and one in the second, that is quadratic. It will graph a parabola. And as you can see, we have two other equations here, the one in the center and the one on the right side, and they now have a constant that's in play being added or subtracted to just the bulk of the equation. It's not applying to a particular part of the equation, it's just hitting the entire equation. Okay, so when this happens, that is causing vertical shifts in the graph. The graph on the left-hand side is a parent function. It doesn't have any changes whatsoever to it. The one in the center, we have the equation y equals x squared. That makes it a parabola. But when you go plus 2, that caused a positive 2 vertical shift in the graph. And then the one on the right, x squared minus 2, caused a negative 2 shift on the y-axis. Okay, so as you can see, the parent function, of course, passes through the origin. That's what it's supposed to do. The one in the middle shifted upward 2 units, while the one at the right is shifted downward 2 units. Okay, we started off with this one on purpose. This is actually the easiest of the adjustments that are going to be made to the parent function. Very easy to read, very easy to understand. And with a vertical shift, the sign of the constant tells us the direction of the shift. Okay, so vertical shift is obviously referring to the y-axis. So a positive vertical shift moves us towards the positive y-axis. That's upward. Negative vertical shift moves us towards the negative y-axis. That's downward. Okay, and the same is going to hold true for all functions, not just the ones that we've talked about thus far, but every function that you can imagine. If you add or subtract to the end of an equation, or the beginning of an equation, it's going to cause the graph to move upwards or downwards. So consider the one on the left-hand side for a minute. What type of a function is that showing? That's an absolute value function. Very easy to spot these because of the deflection that occurs somewhere in the graph. Okay. Now the absolute value function is supposed to pass through the origin. Is this one going through the origin? Clearly not. So there is a vertical shift there, and it is downward, and it is 2 units. What about the graph in the middle? What kind of graph is this one? What kind of function is it? This one is the square root function. Okay, it's a square root function, and the square root function is also supposed to come from the origin. Is this one hitting the origin? No, it's not. How many units has it been vertically shifted? 2 units. And in which direction? In the positive direction. And the graph on the right-hand side, what kind of a function is this? This one is cubic. Very easy to spot the cubic because of the 2 distinct bends that are in it. And the cubic function is supposed to pass through the origin. This one is clearly not, so it does have a vertical shift. How much? 1 unit. In which direction? Upward. Okay, so our equations will reflect those vertical shifts. The one on the left-hand side, we said it was a negative vertical shift. So we got a -2. As we said, it can sometimes show up in the front of the equation. Doesn't have to be in the back. Sometimes can show up in the front. The square root function, it was a 2 units vertical shift, and it was towards the positive y-axis, so +2. And on the cubic, it was 1 higher than it should have been, so we got a +1 vertical shift. The other 2 types of graphs that we have discussed, what's the one going on at the lower left there? What type of a function is that one? That one is logarithmic, that new one that we discussed the other day. Okay, the logarithmic graph. The logarithm function is supposed to pass through the x-axis at +1, 0. Is this graph doing that? Clearly not going through that point. So we need to kind of figure out how has it been shifted vertically so that it is no longer passing through 1, 0 like it should. Okay, well, the graph has had more time to open up, more time to drift away from the y-axis, more time to turn more horizontal than vertical. So how could that possibly be? The graph must be shifted downward to allow that extra time for the graph to open up before it reached the x-axis. So we would be looking at some type of a downward vertical shift. These are a little harder to read how much the vertical shift is until you get more familiar with it, but it is definitely downward. How about the final graph on the lower right? What kind of a function is this? This one is exponential. Okay, an exponential function. So the exponential is supposed to pass through the y-axis at 0, 1. Is this one doing that? No, definitely not. Okay, it is dropped down, so we have a negative vertical shift by how many units? Okay, this one is 3 units further down than it's supposed to be. Okay, so don't get locked in on the x-axis and just start counting away from the x-axis. Count away from where the graph was supposed to have crossed. That's how much the vertical shift will be. So with the logarithm function, it turns out that one was dropped down 2 units, and on the constant function, okay, the constant, I think I called it exponential a moment ago. I apologize. That's right, exponential, because it's got a constant raised to a power, has been dropped down 3 units. Okay, and the flip side of that is instead of necessarily looking at a graph and predicting what the equation is going to do, we will be looking at equations and predicting what the graphs are going to do. Okay, so here are 3 equations. Let's take a look real quick. What type of an equation is the first one? That one is exponential, the constant to a variable. That's kind of a giveaway. And look at the vertical shift. It's not going to cross through the y-axis at 1 the way it's supposed to. It's going to be 1 higher than that because of the +1 vertical shift. So we should be expecting a graph up around crossing at 2. How about the second one, the one in the middle there? Okay, obviously logarithmic, very easy to tell that looking at the equation. And the logarithm graph is supposed to cross the x-axis at 1, 0, but it has a 3-unit vertical shift. That means the graph is going to have less time to open up by the time it crosses the x-axis. So we would expect it not to cross at 1, 0, but much closer in towards the origin because the graph's been vertically shifted upward that gave it less time to move before it crossed the x-axis. And the third one there on the right, obviously an absolute value graph. Okay, the absolute value bars are pretty easy to spot. And the absolute value graph is supposed to cross at the origin. Is it going to cross at the origin? No, we have a vertical shift, 1 unit upward. So let's take a look. I've got a mistake in my notes here. Okay, you have on the absolute value graph, okay, the graph that I'm showing you there is negative. It's been dropped downward. So the formula, the function, should have read square root of x minus 1 because of the vertical shift. Either that or I should have had my graph up above the x-axis rather than down below it. So one of the two had to have been wrong. My apologies. Okay, and then we have two more equations down at the bottom. Okay, the equation on the lower left there, obviously an absolute or square root equation. And square root equations are supposed to come from the origin. This one is not going to do that because of the vertical shift downward 2 units. And the bottom right, obviously cubic because of the third dimension on the independent variable. Cubic equation is supposed to go through the origin. It won't this time because of the vertical shift downward 1 unit. So there are the graphs that would go along with that. Okay, this is basically what we're doing. This is the first step of 3 that we're going to be taking, dealing with various types of adjustments that are going to be made to the parent function. If you still haven't managed to find time to look at the parent function video, or maybe you just didn't learn it, haven't studied it much, I would highly recommend doing that. Unit 2 is going to be basically impossible for you if you do not get a good grasp of the parent functions and what they look like and how their equations read and things like that. Again, I apologize for all the technical malfunctions we've had. Hopefully this one will get it solved. Have a good weekend.